Thanks everyone for joining this webinar. I think we'll get started. There might be a few more attendees coming in the next few minutes. But I'd like to welcome you to the start of RDA Global Adoption Week, which is a chance to showcase the work of the RDA community by talking about the outputs of the interest and working groups and how they've been implemented. My name is Daniel Bangert. I'm based at the Göttingen State and University Library in Germany and working in RDA Europe. And I'm moderating today along with my colleague, Yolanda Mellico from RDA US. A couple of just logistical points to start with. Firstly, the webinar is in listen-only mode, so you should just be able to hear me and our speakers. You're more than welcome, though, to submit questions as we go along. There is a question box in the GoToWebinar interface, and you should be able to enter questions there, and our speakers will address them after each presentation. Okay, moving on. Just to explain the objective of this Adoption Week series of webinars, the aim is to talk about how RDA work has been used and implemented by organizations and projects to solve various data sharing challenges. So we're aiming to highlight instances or examples of how this work has had impact in different regions. And today we have a variety of presentations that are all focused around the broad theme of research data management. The first presentation will be from Tomasz Miksa, who's been one of the co-chairs of the RDA DMP Common Standards Working Group, and he'll be talking about the output of that group related to machine-actionable DMPs. And Tomasz is based at the Vienna University of Technology. Our second speaker is Rob Quick from Indiana University. He'll be talking about the implementation of a couple of RDA outputs related to data typing and the PID kernel information. And lastly, we have Mijke Jetten, who is based at the Dutch Tech Center for Life Sciences in the Netherlands. And she'll be speaking about a group project that adopted the 23 things for research data in the Dutch context. Firstly, before we get started, just to gauge who's in our audience and why you've joined the session, I'd like to invite you all to go and complete a brief poll. So if you could go to this site, slido.com, and we just have a few questions here for you to answer. The first one is related to your primary role. So if you go to slido.com and enter this code, #W340, and just give us what you consider your primary role to be. So I see a lot of answers coming in. Great, research support staff. Excellent, project managers, others. Some researchers also. Okay, quite an even split there amongst several of the categories. Excellent, thank you for your answers. We'll move to the second question now. So I'll move the poll on, and the next one just relates to your primary domain. So this will help us get a sense of the context in which you work. So which of these would you consider your primary domain? Very nice. Okay, so we've got several that are working across domains. Some natural sciences. Okay, engineering and technology, medical and health sciences, and so on. Very good. And just to the last question now, to help our presenters understand why you've joined today, if you have a burning question related to research data management and the RDA outputs that you would like to learn about, what would that be? So is there anything you're really interested to hear about today? Okay, yes, we've got some DMP tools there suggested, 23 things. Machine-actionable DMP is excellent. Practical examples of implementing the DMP common standard. Integrations, very good. Okay, someone was joining the hackathon and would like to see examples. Great. So we should be able to address at least some of those during the presentations. The focus in this whole series of webinars is on adoption. So understanding how the outputs have been implemented, which Tomasz will address in relation to DMPs. And the second two projects have had funding from different regions to help the implementation of RDA recommendations. I would like to get an overview of what is going on in RDA and get a chance to connect to people that care about data. That's great to hear. Okay, thank you all for those questions. I think we can switch back now and I will hand over to our first speaker, which is Tomasz.
Thank you.
Please go ahead.
Okay, give me a second. I guess you can see my screen right now. So thank you very much for the invitation to the webinar. Welcome everyone to the first topic on machine-actionable data management plans. I see there is quite some interest from your side. In this presentation, I'm going to give you an overview of what we did, why we did it, and I will try to provide many pointers to resources that you can check out later to learn more on what's going on, what has been implemented, what's working, what is still being developed. So I'm sorry if I'm not able to go into the details on specific questions, but feel free to contact me after the presentation and I will help you to answer all the questions you may have. So let's start with a bit of motivation and how the DMPs look like currently, so traditional DMPs. This is an example of a template I took from the funder in Austria. And as most of you know, it looks similar in other countries. So there is a list of questions researchers are supposed to answer, usually at the beginning of the project and maybe then at the end. And what they do is they write a lot of text and they think this is kind of a bureaucratic problem, always considered to be part of a project proposal, and such DMPs don't create much value. They're only written to make the funders accept the project mostly, and they're often completed last minute. So there is a lot of important questions being asked, a lot of information that could be needed, but they are not really considered seriously in many cases. Of course, the problem is not only that the researchers only have to write it, but they also very don't know which tools to use. So we have tools like DMP Online or Data Stewardship Wizard to go through the process of writing a DMP. We have the free data to look for repositories that actually one can describe in a DMP. We have a license selector from EU DATS that can help you pick the best license for your data. We have persistent identifiers like DOI that help us do the data management correctly. But For a standard researcher, and you, as most of you are working in the research support know, the problem for most of the researchers is that they don't know which tool to use, and is it enough to use only one tool or 3 tools, and why do they have to provide the same information all over again? It's not really clear to them. And what's even more problematic is that many things described in DMPs have impact on other stakeholders within the research lifecycle. So researchers describe something, like, for example, they say we're going to use the storage provided by the university, but they don't consult it with the IT operator of the storage within the university. And then the projects got accepted, and the researcher starts producing the data and comes to the operator and says, now take my data. And they say, like, but what's going on? Who's going to pay for this? So there is a lot of such miscommunications and basically lack of communication. So one of the hypotheses we had when thinking and developing the concept for machine-actionable DMPs is that when people are contacted at the right moment in time, they can provide information and the quality of DMPs can be improved. So if there is a need for information on licenses, a legal expert can provide it, but he or she must know enough to be able to provide good advice. It cannot happen 5 minutes before the submission of the proposal. Same for the research support, for the policymakers and others. So many problems can be avoided when we have the right timing and the information flow is ensured between all the stakeholders. Here you can see an example of a typical workflow that people follow when writing a DMP. And using this workflow, I would like to explain you how we can improve the experience for the researcher and also for the other stakeholders with a use of machine-actionable DMPs. I am not defining yet what machine-actionable DMP is. Right now, let's focus on the steps and what kind of decisions we have to do at each step. So usually a researcher starts writing a DMP by providing some administrative information. This is information like email, name, affiliation, and so on. Most of this information already exists in the systems like CRIS systems or any other system that is managing users within an institution, within a university, or maybe RDA. So why not to reuse this information from the system, and why not to evade entering the same information all over again? The next step is describing the data, and this is the step that the researcher must do. So he or she must tell us what is the size and type of data. For example, the researcher can say that I'm going to produce 2 GB of PDF files. And already on this, based on this information, we can estimate the cost of storing these files, of managing these files. We can actually book some storage and also get a license. And these 3 steps can happen semi-automatically because for the majority of cases, the recommendation can be provided automatically. So for example, if a university provides storage services, and if the storage is within a certain limit, let's say up to 20 GB, this can be automatically granted, and the information can be passed to the infrastructure operator that there is a demand for storage. Same for the cost. If an institution has a cost model, it can say, okay, this amount of storage will cost you this and this amount for the period of the project. And same with the licenses. I can see here in the list of attendees some colleagues who tell me this anecdote from Gdańsk that 80% of the researchers, when they were asked whether they have to decide what the license is or the library decides, they picked that the library should pick a license on their behalf. And this is exactly the same setting. If the institution recommends, for example, a CC BY license, this license can be recommended automatically. And only in special cases, human interaction can be needed to discuss the specific case of using a different license or maybe keeping the data closed. And once these steps are completed, there is a chance for a researcher to review the plan and then submit to the funder. And here again, we want to have a connection to the funder systems so that it's not again about generating a PDF and sending it as an attachment to the mail and forgetting to attach a PDF, but really integrating with funders to pass the information directly to the funder. So to make this workflow happen, to realize it, we need three things. We need well-defined research data management workflows. So we need to know who is responsible for what. We need infrastructure that supports these workflows. So for example, we need a service that grants the storage to the user or suggests a license. And we also need a common data model, common way of exchanging information. And machine-actionable DMPs are this common data model, common way of exchanging information that makes the information contained in DMPs machine-actionable. And the goal for us is to make MADMPs living documents that are updated regularly, that can be easily checked without an expert needing to read the text, but simply checking some of the fields, and to be able to make the machines make decisions based on the contents of the DMP. So if there's a certain field and it's set to this value, the machine can make a decision. But just let me give you some more examples in the next slide. So before we jump to showing an example of what an MADMP is, just one clarification: common standard for the MADMPs is not a common template, a common questionnaire. So it's not about having a unified set of questions among different funder templates. It's about making a way to transport information independent of the template. So the funders can ask different types of questions, and we want to model the information contained in the answers so that we can exchange this information between the systems. So here's an example. At the upper part of this slide, you can see a traditional DMP where we have a question answer. And in this setting, you are not really able to make any query, easily make a query without making any text recognition. So if you want to check who is the principal investigator, it's not really easy. And then the answer can be generic, it's John Smith. We don't know which John Smith. There can be several John Smiths, and our university, depending on the context, it can mean everything. And in the lower part, you can see basically the same information, but made machine actionable. So it follows, it has fields which are explicitly stating what the role of a person is. So in this case, we have a creator, John Smith. The Smith also has an identifier, so we know exactly which John Smith. In this example, it's E-RPID, but it can be any other identifier. And also the institution is explicitly described. And this is what makes the DMP machine actionable, when it consists out of a set of fields, and each field has a really well-defined meaning and not just a fashion question answer. So this, what I described, was part of the discussion we had in the workshops in 2017 and also at the RDA plenary. In 2017, there was a decision to launch a working group which focused on working on this common specification for machine actionable data management plans. And currently we have 200 members from all continents, and all major DMP tool owners are part of the working group. And now just quickly to tell you what happened within the last few years so that you get a better feeling of what RDA is and how the working groups work. So within the working group, we made here 5 major steps. First, we wanted to understand what should be the scope of machine actionable DMPs. And we made consultations. We made an online consultation with user stories, and we also ran some stakeholder workshops in different parts of the world. And the goal was to define the scope so that questions which are asked and later modeled in this template are really questions that people want to hear the answers for. Many questions in the templates for the DMPs are there because somebody thought it's nice to ask them, but nobody is actually using them. So if we ask about the storage, there is clearly an IT operator who wants to know how much storage there is. If somebody is asking about the licenses, there is, for example, a legal expert who must ensure that the license given to the data is according to the policy of the university, and so on. And thus we defined what should be within the model. So it's independent of the specific template. In the second step, we discussed with the experts what are the existing models, ontologies, taxonomies we could reuse when defining the model. And then we started developing proof of concept tools to demonstrate how similar workflows to the one I described can be implemented and how can task in data management when we have this common model that allows different systems, different services to exchange information. And to make it a bit more abstract and generic, we defined business processes to depict some general use cases in which machine-actionable DMPs can be deployed. So, for example, if you want to use MADMPs and you want to provide automatically information on costs, what you actually have to do is to have a cost model for your services. So it's not really only about adding a support for MADMPs to your tool, but it's about looking at your own organization and identifying gaps. What kind of gaps you have in your research data management support workflow or in your systems to make the whole experience for the user much simpler, much faster, and simply to evade asking the same questions all over again. And finally, we did the model development, but based on all these experiences, we came up with an output. And this is the official RDA output. Here you can find the link in this slide. It is a two-pager which describes major classes and provides a link to the more exhaustive documentation in GitHub. The documentation in GitHub consists of a set of tables. So in each table you have a property which has a defined description, data type, cardinality indicating whether the field is optional or obligatory, and some examples. Most of the fields are optional, and everyone needs to customize which fields should be used in a specific setting. So we didn't want to enforce any funder context-specific requirements on the common standard. We wanted to make it possible to be reused across different institutions, different countries, different stakeholders. If you want to learn more about the standard itself, if you visit our GitHub repository, you can find there frequently asked questions. If you read through them, you will get a better feeling on how the standard works and how it's structured. There's also a page with links where you can read about the consultations we did, about the reports from the workshops. You can find links to the proof of concept tools. So a lot of interesting resources that can make your imagination thrive if you're still not sure how to use the MADMP in your context. For developers and IT specialists who are going to implement them, we have some JSON examples. We also have a JSON schema, so you can play around with the specification itself and see how it looks like. Here is an example of a minimal MADMP. So as you can see, this is a set of fields. Here is a title for the DMP, minimal DMP, a contact person identified by ORCID ID, it's Charlie Chaplin, the creation date, the DOI for the DMP itself, and just one data set which is actually not specified. We don't know whether there is any personal data or sensitive data, but we know it has a DOI as the identifier. And that's basically the minimal set, and there are many optional fields that you can add to provide more information. When it comes to pending adoptions of the standard, and this is what's important for us to see that our work actually makes sense and is being taken up. Here is a list I compiled like 10 days ago. So we have the DMP online in the UK, we have the DMP tool in the US, we have colleagues from France, from Germany, from Elixir, Netherlands, and Czech, OpenAir, and Greeks. We have one of the research publishers in the UK. Also, recently we had webinars with colleagues from Norway and from Sweden when the MADMPs are being used in their data management infrastructure. Haplo is the first commercial repository, first commercial product which implemented the standard and deployed it last month at the South Bank University in London. And we're also implementing the MADMPs within Fair Data Austria project in Austria, in which 3 major universities are going to use it. Last week, we had a hackathon on MADMPs, and this is also a great place where you can find many resources. We had 71 participants from 21 countries, and they worked on integrations, mappings, etc., using the common standard. And please go there. There is a recording of the session in which everyone presented the results, but you can also find links to individual teams and to outputs produced by them. So you can see here what the DMP tool providers did, but also what has been done for integration with repositories, and also with ontologies. There is an ontology for the common standard, as well as some discussions on integration with OpenAir and the graph created there. So a lot of interesting inputs. If you want to stay in touch and follow what we're doing, we have 3 options to do so. We have the Active Data Management Plans Interest Group, which is an umbrella group for all the topics related to data management, but to making data management plans active, machine actionable. So you can bring your new ideas to this interest group. If you're interested in making the DMPs public, in this case, we are using the word exposing because it allows to support more use cases, then check this working group. They are currently producing a recommendation, an output. And if you are interested itself in the standard, in the common standard for making DMPs machine actionable, please join our working group. And we are not sending too much emails, but if you join it, then we will inform you anytime there is something new going on. So this is an example of an RDA page. You have to be logged in, press the join group button, and then you are subscribed. In case you are going to implement the recommendation, please let us know that you're doing that. We are collecting adoption stories. It gives other confidence that reusing the standards could make sense in their setting, and this is what we really would like to see. So please let us know if you are considering or partially adopting the standard. It's very important to us. If you want to read more, here's a list of publications. You can have a look. The first one, 10 Principles, describes in general what you need to make your system machine actionable, and then there are some descriptions of what we did to develop the standard. And that's all from my side. Thank you very much. Go check out the specification, adopt the model. In case you have any questions, please contact me after the call, send me an email, or you can contact also my colleagues who are the co-chairs of the working group, Paul Walk and Peter Nish. Thank you very much.
Thank you, Tomasz. And just a note that we will be sending these slides to you via email afterwards, so you'll have access to those links. We can maybe take 1 or 2 questions before we move to the next presentation. So if you do have a question, please enter that into the question box. And in the meantime, I will switch over to Rob. Okay, no questions coming in for the moment, but feel free to put them in there if something occurs to you. And let's move to our next presentation then from Rob Quick, talking about the SEAGrid project.
Hello, and can you see my screen?
Yes.
Okay, very good. So good morning, good afternoon, good evening, depending on where everybody may be. I am pulling up my slides right now. And now you should see my title slide. So I'm going to talk today about a project that was funded by the RDA US and Adoption Project, where we took a science gateway, SEAGrid, and a science gateway is known by many things, depending on where you are. This is a virtual research environment, a virtual platform, a science portal, or a science gateway. Regardless of what it's called, it's basically an abstraction of the computing complexities behind the scenes and giving the researcher either a web page interface or maybe a client interface to do their work with, and basically abstracts away all the complexities that are going on behind the scene. So this work was done by myself and Yu Lao and Guanchen Ran here at Indiana University. And as Tomasz said, if you have any questions about this, my email is here on the slide. I don't know how much time I'll have to answer questions here today during this adoption session, but please feel free to reach out and contact me if you have any questions about what I go through. In the demo or in the presentation here, I hope to talk about what SEAGrid is, talk about the Rapid. Rapid is a test bed that allows PID infrastructure to be accessed, or a digital object architecture, many call it, or fair digital objects. Then we'll talk about those two systems that are integrated together. We will do a brief introduction to the adoption project, talk about implementing FAIR from a technical perspective, or what FAIR means in the form of infrastructure and what can be done really before you begin your research to make the data products and in fact every step of the data more fair. We'll do a quick demo, and I hope to keep that very, very quick. And then we'll talk about PIDs during these computational workflows and get to my conclusion. So keep in mind that this scenario is for researchers who use a science gateway to do their research. They're concerned with digital objects they use and produce, and they want them to be fair. They want their work to be reproducible beyond the science gateway. So they want to be able to hand it to somebody who doesn't necessarily even know what science gateway they're using, or what virtual research environment they're using or accessing, or may not have authorization to access that, but they still want the data to be reproducible. So something that's independent of the research environment that they're working in. And they want to share these steps, not just share the data at the end of the workflow, but share the steps on how to recreate or reproduce the calculations and analysis that are being done, and to share that easily with their collaborators or within a publication. And then they may want to reproduce a workflow with some tweaks, either running new data with it, updated data, maybe changing software versions, or some other way, tweaking the workflow that they've done previously to come up with new results. And they don't want to have to recreate the entire computational workflow from beginning. So this is really who is targeted with this work. And before we go on, I'm going to remind you of the FAIR principles. The FAIR principles are pretty important here. And this slide, Luis Benino from Leiden produced and pulled out really what's in green here in the FAIR principles as what we could potentially have a technical solution for. And the stuff that's in blue or black, depending on your screen, is more of the community instituted standards that really the technical framework allows but doesn't enforce. So just a reminder that findable really is contingent on having globally unique identifiers, or PIDs, being able to describe data and metadata, or with metadata, and have that explicitly include some identifier to the data it describes. Accessible means that these are retrievable with a standard protocol, and that protocol is open and free, and allows authorization and authentication when necessary. What I show you today, authorization and authentication are not necessary, so we won't talk too much about that. And then the data type registry, which is again a RDA output, is used for this interoperable step where you have a accessible shared language for representing the knowledge. All the data that is captured is also typed in a data type registry. So you can actually have, machine actionable or human readable forms of what the data really means when you get a piece of metadata or data. So SEAGrid itself is the science and engineering application grid. This is a gateway that is built with Apache Aryavada and that middleware framework. And this adoption really, and what we've done is looked at small molecules and their fluorescent properties. This was the science use case behind this. With it being built on Apache Aryavada, we can then, if we can do this one single use case, we can plan to extend to the mini gateways. I think there are somewhere around 40 of them hosted at Indiana University at this point that use Apache Area of Audit as the middleware framework. So this is then easily integrated, or at least able to be integrated with other science frameworks that may use this work. So the Rapid Testbed itself really came from work done within the Data Fabric Working Group of RDA. It's a cyber infrastructure for minting PIDs, resolving those PIDs. It includes a data type registry for describing the metadata, and then a protocol called the Digital Object Interface Protocol for doing operations based on those digital objects and the metadata that is captured there. So basically, this is a cyber infrastructure to implement the technical components of the FAIR principles, or some of the technical components of the FAIR principles. And it leverages several RDA outputs and recommendations. The PID kernel information strawman profile is a profile of metadata that is captured within the data type registry that basically defines some set of fields that are necessary to do for the protocol to do the operations. It has some base required metadata, profile fields that allow basically both the technical locations and the provenance information and such. And this was produced again by the PID kernel information group. It uses a data type registry where all of the data is typed for both machine interoperability and then for readability and adjustment. And it really heavily heavily leverages the work done within the Data Fabric Working Group, where it was really conceived that putting together some of these outputs into a fabric of services was really the next step along the lines of creating a data fabric or a data cyber infrastructure. The Rapid was funded by the National Science Foundation in the US, and if you want to learn more about that project, the link is included here. So the RDA Adoption project was really a 6-month project to see if we could take these small fluorescent molecules and integrate them with PID services that E-RPID allows, or Rapid, and provide some fair, so provide a version of a fair science gateway. Really, this workflow here, this generic workflow, it describes the steps from raw data through some preparations or data munging into intermediate data products. It's sent through some number of iterations to a final data analysis, and finally final products. This is again a very generic version of a workflow. They're much more complex than this in the end, but you can see along the bottom that we're assigning PIDs along every step. So the raw data, the intermediate data, and the output data, or the final data products all get PIDs, but along with that, the software used for the varying steps of the workflow, and really the workflow is defined within PIDs that can then be resolved, and you find metadata about the individual steps of the PID. And I'll show a simple example of what that looks like shortly. So and I guess I'll show it now. The workflow PID looks something like this. So when you start a VRE run, it's assigned a workflow PID. This is split into 3 basic parts, and this is again a very simple workflow where you have input, you have some set of software, and you have output. Now, from the input, this splits into various different, both the data and the various different commands that are fed to the computing. In this case, the data consists of a molecular charge and then the coordinates of the individual elements within the molecule. You can see here that this looks like a tree. In the end, this probably workflows are much more complex than this, or real science workflows. So it would look much more like a directed acyclic graph than it would a tree, but this gives you a simple idea. And basically each of the steps along the way and each of the pieces of metadata involved with the run are assigned to PID, so you can potentially replace or, as I said earlier, tweak workflows with something like just a new software update or a new set of data, or you can compare the outputs to new runs, whatever it may be. These can be mixed and matched by knowing the PID. So looking at the time, I will do just a very quick demo here. Oops, before I go into conclusions. So what this looks like in real life, this is the SEAGrid homepage. It's available at rapid.seagrid.org. If you log in here, you're given a login prompt, and I'm going to use Gaussian 16, which does computational chemistry and does some molecular modeling. You pick an application. In this case, it brings up what is the start of your workflow. You can see here it gives it a timestamp. It's putting it in my default project. I'm going to add a file here, and this is neopentanediol, which I did wrong. Okay, so that uploads this basic molecule. The great thing about this is as soon as you start your workflow, so you hit this save and launch button, it does the calculations, but it immediately gives you a workflow PID that is resolvable externally. So you get this PID, you can go to handle.net and get some information about it immediately. So if I put that in here, oh, I had a copy and paste error. Now I went back too far. So let's see. Maybe I didn't paste it all. So that's the problem with doing live demos, right? Is you run into potential problems. So I will see if I can pull up a older one that I've done previously. And you can see here, this is the Gaussian output data for a previous run. It's recorded immediately. You can find more information about it. This gives a creation date when it was done. If I dig a little bit deeper, I can find out the URL of the data product. So following this login, you can get to the end data product. So I'll go back to my presentation because my demo went midway south. The important thing there is that as soon as you hit save and run, as this is before it's even queued, you get a PID that is then persistent and described external to the gateway. So let me put my slides back up here again and go with the conclusions. So SEAGrid has been integrated with the Rapid Testbed services to implement fair science workflows. We're currently exercising this with the remainder of the adoption time, which is basically until the end of the month. We're going to run as many of these fluorescent molecules through the system and see if we have any issues with this. We're hoping to get tens, if not a few hundred, of these fluorescent molecules run through the system. These are all assigned workflow PIDs, which basically record the entire computational process used, including the software, the input, the output, and any parameters fed to the computing. And with the PID, you could basically recreate the entire computational workflow externally, knowing nothing about the virtual research environment or science gateway. Though you probably wouldn't want to recreate it. A more realistic scenario would be, as I mentioned, you want to run some new data through it. You want to replace your run with a newly released software version. You want to feed some different parameters into the workflow to see if you have if they match the results. And there's no access necessary for SEAGrid or the gateway to have the information you need to recreate a workflow. And as you saw from my FAIR slide, this directly inputs the findable, accessible, and interoperable principles, not as much the R, but it really builds that foundation that you can get to a fair data, or I'm sorry, a fair science gateway. In both the metadata is extendable, and this is extensible to other science gateways based on area of ADA, but we're hoping to produce best practices for other gateway type softwares or middle or frameworks, so people can use a piece of software that allows them to reach out and basically stamp these PIDs on various items within their workflow. We'll produce both a piece of client software that allows interaction with a handle service and DTR, and then some best practices along with that. And as I've said several times, but I'll reiterate here because it's the reason I'm talking today, that this project leverages several outputs made available by the RDA community. And in fact, these fair science gateways in themselves could not exist as we've done in this project without the RDA community. So I'll wrap up there, and don't know if I have time for questions or if I ran long there, Daniel.
Yeah. Thank you very much, Rob. I don't see questions, but if there are some, you can enter them into the box and maybe Rob can type answers. I think for the sake of time, we will move on. So our last presenter is Mijke Jetten, who will be talking about the 23 Things Revisited adoption project, which was conducted in the Netherlands. Micah, please go ahead.
Yes, I hope you can hear me. I have some issues with the tool. Is it working?
Yes.
Yes, great. So I will be presenting, as Danielle introduced already, about the 23 Things project. And I have Cees Hof with me to help me out a little bit. He did the part of the tool, so I'm really excited to show you a bit of what we are currently doing in the project. And just to be clear, this is well, part of a bigger Dutch initiative. We have a Dutch national coordination point on research data management. And within that bigger group, we set out abroad in the Netherlands this RDA adoption project. So this is a quite strong collaboration in the full Dutch society. So I'm really excited about what we were able to do within the RDA grant project. So if you can switch slides. Yes. So I'm not sure whether you all know the 23 Things resource. It was originally drafted by the Libraries for Research Data Interest Group, and it included about 23 tips, as the name suggests, for libraries or for library staff to start working on research data management. Well, we were really excited about the existence of this resource, but we thought it could be updated and also be adjusted to different audiences, and those audiences would be able to use it as a shared reference tool for knowledge within their own discipline and their own kind of people on research data management. And by adopting the 23 Things output for multiple audiences, we expect it to be improving national cooperation and a common understanding of RDM across, well, a lot of different practitioners and supporters, at least within the Netherlands, but I think we have a very broad scope within the project. Well, we're currently still working on the output of the project, but we did most of the steps already, and we're currently into the phase of setting out the tool and dissemination phase. What I'm going to tell you today is, well, we have 3 parts, so a summary of the project, and then a showcase of the 23 Things tool. Just to be sure, we did it via slides and not a live tool because it's still work in progress, but it will pretty much show what we envision the tool to be. And then we end up with, well, showing how you can contribute as a potential future adopter of a similar project or of a user of the tool. So if you can switch slides. Thank you. So we have 4 phases, and I copied and pasted from, well, a few slideshows from posters we did all over the, well, during the project. And the first phase was creating a Dutch nationwide commitment for the project. I told already, it was for, well, at least within the Netherlands, really relevant to have a lot of people on board, organizations on board on this project. And we've written an implementation plan, including communication aspects, and we shared it with our pool of experts within the National Coordination Point, research data management, and other Dutch stakeholders. And if you're interested, you can use the link, because we put all our output on Zenodo. If you click the link, you can check out our implementation plan. So next slide, please. So the second phase included adjusting the 23 things. So as it, well, the resource is from 2015, so it's already a bit outdated, we noticed. So we start with creating, well, what we call a local version of the 23 things, originally for the Dutch community. So we updated relevant links, included GDPR, open science, fair resources, but we noted that hardly anything is typically Dutch, so it's more by the Dutch community than to the Dutch community. And we tend to include different audiences, as I've mentioned already, and which I'm going to show you as well. So the first version, a kind of intermediate version, is available on Zenodo, and you can click it by using the link. But we've already improved it in the third phase, so you better use that resource. So the next slide, please. So what we did, we asked input from the different stakeholders and audiences in the Netherlands to create 23 things versions for researcher and PhD candidates, for students, for data and subject librarians, for data stewards, for IT support staff and specialists, and also for research software engineers. And we also included policymakers. So we figured out in the Dutch community that while having just one version well, it was originally developed by the library, so it kind of focused at the library. We figured out that there were many different communities that could benefit from the 23 things. So we asked input from the broader community to add to those different resources. If you click the next slide, please. So I'm later on going to show you a bit of the outcomes of the 23 things versions, but I wanted to add that in the third phase, which is the phase we're currently in, is we're trying to get those 23 things adopted as well by those communities. So we asked them help to put input for different audience versions. We also wanted to include those in existing trainings in the Netherlands to be able to see whether the different audiences could work with those versions. Well, we had to adjust that a little bit because due to COVID-19, we couldn't do any live sessions, but we transferred it into an online tool. If you go to the different slide, next slide, sorry. Well, we have phase 4, and phase 4 includes dissemination of our experiences and final versions. So that's just a lot of outreach. We're currently trying to well, make steps in. So next slide. Then a little bit on the output. So as I've mentioned already, is that we created 7 different versions for different audiences on the 23 things. And these are just 23, in most cases more than 23, straight tips with resources you can click on different things, such as data management plan, trainings, citing, coding, etc. So a lot of relevant resources. And what I wanted to show you, if you click, if you do the next slide, please. Thank you. We've drafted those well, kind of static versions that are available on Zenodo into a tool that allows you to add to those different resources, but also allows you to kind of draft a learning path of the things that are interested to you as well, coming from a specific audience. So what we've done, it's only a beta version, so the slides are a bit better than the live version yet, but it's work in progress. We took all the 23 tips times 7 and put them into a database. And based on that database, we have those 7 audiences still available in the tool. We have 16 different themes that are relevant for those audiences. We have 13 more different types of resources that a user could pick from. And then we have the data lifecycle included in the tool as well. You can really see it's work in progress because there aren't 11 options. It's actually 6 options, but the database isn't updated yet. So if you're really curious, you can click the link yourself, but we included some slides to show you our experiences. So if you do the next slide. So this is Boris. I want to introduce you to Boris, who is a postdoctoral researcher at the TU Delft, one of our universities, and he has shared his code with one of his PhD students. And she asked him, how should I cite this code software in my thesis? So if you go to the next slide, then you can see that Boris selects his audience. He is a researcher or PhD candidate. Next slide, please. He clicks his theme. Well, his theme is citing data and coding because that is where his PhD asks about. Next slide, please. And then he gets, as an answer to his request, 2 resources. So an example how to enable software citation and promoting the scientific value of data encoding. So if you go to the next slide, there you can see the first resource Boris gets. With the help of the tool, he's able to follow the FAIR software route and help him choose how to cite his software best. Next slide, please. And Boris gets another reference via the tool. He gets a Force 11 resource on how to do proper citation following those Force 11 guidelines. Next slide. So via the tool, Boris and other users are able to design their own learning path. So they can choose between their audience, different themes, different types, different phases of the life cycle to get their own needs. If you go to the different slide, next slide, that is, and it's shown. Thank you. So for instance, based on your own learning path, you're able to access information as a data steward on data management planning. You get the resource of Purdue University libraries on data management planning and self-assessment questionnaires. Or you get the resource on guidance for review of data management plan by the National Institute of Standards and Technology. You also get the resource on Scientific Europe with practical guidelines to international alignment of research data management. And there we have a typical Dutch resource. You also via the tool get access to the NWO, which is one of our funders' DMP assessment rubric. Go to the next slide, please. Thank you. So this was just a quick showcase of our 23 Things tool. It's still work in progress, but we'll expect to release it for the full version in about a month's time. And I think the nice aspect of this tool is that it includes the first phase, an email address in which you can use to add your own things to the tool or adjust broken links or do suggestions. In the near future, we're planning to increase that a little bit, so make maybe a add resource button, but that's just a beta version for now. So if you want to contribute, if you have specific resources that could be included and that are relevant for different audiences, please contact us and we'll make sure to include your links to the tool. Thank you.
Thank you very much, Micah. Yes, and as said before, we'll be sharing these slides so you can contact the presenters directly or get in touch with RDA as well. I just want to take 2 more minutes then for wrapping up. All of the outputs, the recommendations and supporting outputs that were discussed today are available via the RDA catalog. So you can also search those through the data lifecycle which is also how we've structured this adoption week according to different themes. We're also keen to hear from you if you've implemented any of these outputs or any of the other outputs from RDA. You can go to this link and tell your adoption story. This helps to motivate others to understand what the experience of adoption is, what's required for implementation, and helps to show the impact of the great work that RDA is doing within the groups. There's also a call for papers out. If you would like to contribute to a special journal issue, it's the CoData Data Science Journal. There's a special collection on RDA results, and you can see the published papers there, as well as there's another month to go to submit papers which will have their APCs covered by RDA Europe. And finally, this is just day one of the Global Adoption Week, so you're warmly invited to join the other sessions where you'll hear about other RDA outputs and how they've been used, looking at, again, different themes, so data description, identifying, storing and preserving data, disseminating, linking and finding, and issues to do with policy, legal compliance and capacity. So it just remains for me to thank you again for attending. We will be in touch afterwards to share the slides and recordings, and please feel free to reach out at any time if you have questions about what was presented or about RDA and the RDA recommendations in general. Thank you very much.